Here is part 2. We are finding our x-intercepts of quadratic functions. First, we did it by factoring, which is all this work here, and we got 1/2 and -9/2. Okay, but now I want to do it in vertex form. So let's actually graph our function. Here it is. Here's our parabola, and we can see that our intercepts are here at 0.5 and -4.5, which is exactly what we want. Vertex form here, here's our vertex, -2, -25. Let's start typing in this function so that it'll start graphing. X minus -2 is x plus 2, close parentheses, and I square it because this is quadratic. Then I subtract 25, but it needs to be exactly the same. It needs to be stretched the same as the purple. So actually right in front, our leading coefficient of our blue one needs to be the same as the leading coefficient of our purple one, which is a 4. And there we go, we got the same thing. So there's our function, now written in vertex form. Let's remember that. We have our same function f of x, but now it's written as 4 times x plus 2 squared minus 25. Okay, so our goal is to solve for our x values when our function value is equal to 0. So I just set it equal to 0. Now we just need to get our x all alone. So I'm going to add 25 to both sides. Okay, and I get 25 equals 4 times x plus 2 squared. Now, next step is divide by 4 on both sides, and we get that 25 over 4 is equal to x plus 2 squared. Our next step, in order to, get rid of our square, we need to take the square root. So I square root both sides. On my right side, the square root of something squared is just that something. It doesn't change, x plus 2, which is on the inside of our root. Then, if I take the square root of 25 over 4, I can have a positive or a negative of it, okay? The last step to get my x all alone, I need to subtract 2 from both sides. Because these are not like terms, I am going to just write it as, I'm going to write it over here, -2 plus or minus the square root of 25 over 4. Those are my x values. Now, since this is the same function, are these the same values that we got up here? No. So let's remind ourselves of the property that when I take the square root of a fraction like this, some number over another number, it's actually the square root of the top over the square root of the bottom. And the reason I want to do that is because if you notice, 25 and 4 are both square numbers, which means we can easily find our integer value. We're going to get -2 plus or minus the square root of 25 over the square root of 4, which is x. -2 plus or minus, what's the square root of 25? 5. What's the square root of 4? 2. Are those the same x values that we got up there? No. So let's just write it separately. -2 plus 5 halves, or x equals -2 minus 5 halves. And let's think about this in decimals. X equals -2 plus 2.5. If I have -2 and I add 2.5 to it, I'm just going to get a positive 1/2. And here is x equals -2 minus 2.5. If I have -2 and I'm subtracting, I get more negative, and it's going to be a -4.5. There we go. Those are the x values that we got up there, which is good because they're the same function.